Well, thanks everyone for coming to our session. Just to understand who's here, raise your hand if thinking about your application portfolio, you would say you have a fair number of monolithic applications. That's good. That's good. Of those monolithic applications, I was actually expecting more hands. Kind of wondering why you're here. Maybe Kurt's session is full. But you know. Of those monolithic applications, who would say they contribute significantly to the revenue or the mission of the firm? Right. Okay. So you have monolithic applications; they're reasonably important. Who here has heard of the strangler pattern? Okay, who just turned up because strangler is cool and it's in the title of our session? Back to the folks who had the monolithic applications. Who here occasionally wants to strangle their monolithic applications? Nice. Okay, well, some of you are in the right place, and hopefully all of you get some value out of it. My name is Kenneth Jackson. I'm a principal solutions architect here in the Global Financial Services Group at AWS. I've been at that a couple of years, and before that, I did lots of other things in the IT industry, mostly on the vendor side, selling to and helping large financial services customers use technology to transform. My colleague here, Christopher Marsh-Borden, has been on the other side of the house and spent much of his career until recently, when we grabbed him away, on the bank side, trying to use technology to accomplish their goals. And so we do want to talk to you about is the challenge of monolithic applications, and hopefully you come away with a new pattern, one that we haven't talked much about before, about how to migrate those to the cloud. And I think Chris is going to define a couple of terms first.
Yeah, so we want to be clear. My mic on? Okay, we want to be clear about this. So monolithic applications, this is the dictionary definition of both monolithic and heterogeneous. Monolithic, big and large. In terms of applications, it's a single deployable artifact. So if in the Java world, it's a jar or war. If you're in COBOL, it's an application, and obviously it's a package in the .NET world. So it's something large and cumbersome. We specifically strayed away from using terms like microservices for this presentation, because what we're actually stating here is not you need to go to microservices or you need to go to functions. You can do a combination of both. All right, so heterogeneous, varied, diverse, and our implication is much smaller than monolith. So you're reducing the footprint of the deployments that you're putting out there. All right, so I just want to clarify what we mean in our terms.
Okay. So over the next 35 minutes or so, hopefully we'll leave a little time for questions. We want to remind ourselves, why our customers are migrating to the cloud. The cloud is a means, not an end. It should help you accomplish business value, right? Saying that your application is now in the cloud, you haven't yet really said anything. Like what impact did it have on the business? So we want to remind ourselves what patterns we see from customers and the value they're getting. Talk about some of the challenges of doing that and some of the patterns that have emerged with us working with millions of customers, with millions of applications, and helping them move them to the cloud. Review a bit of the state of the art. What are our documented current strategies and patterns for moving? But really the meat of the talk is introducing a new pattern. So we're going to leverage this strangler pattern, and for those of you who don't know about it, we're going to keep you in suspense a bit longer. I will give you a hint that it's botanical in nature, not homicidal in nature, but that's where it has its roots as a metaphor. But talk about this pattern and how you might apply it towards your monolithic applications and what some of the benefits are. So just to review, again, why are customers moving applications to the cloud? And there are many reasons, but if you summarize them, some are time-based. That time could be either I need to respond to market forces. I have a challenger in the market or a market opportunity, so I need agility to move fast. Some might be time in a contract, like the lease on this physical piece of property or this software contract is expiring, and I don't really want to renew it. I don't see value in renewing it. Others are cost-based, right? Either my cost structure is too high for me to be competitive, and I've got to take cost out. If we've been in IT long enough, many of us have been in those kinds of scenarios. Or cost-based in terms of there is a new revenue stream, and I need to take advantage of it, right? So lots of reasons to move to the cloud. The challenge, though, is how do I make sure that I'm going to act on that market opportunity? How do I make sure that the migration path that I choose is going to fit in the time required so that I don't have to renew that contract? And who has seen the AWS migration white paper? We love white papers at AWS. We publish many of them. Yeah, if you haven't seen it, I would definitely encourage reading it. It's well done, and when we write these white papers, that's the harvesting of best practices from working with real customers. We don't presume to be all that smart here at AWS. We tend to learn a lot from our customers, but we try to see those patterns, take the time to put them down in narrative form and share them, and then keep revising those. I think the latest revision of the AWS migration white paper was just from the middle of last year. But if you pull up the white paper, they'll talk about 5 considerations when moving to the cloud. Five axes or dimensions you should use to evaluate, strategy A versus strategy B, or even, is this application the right one to migrate right now? And those are the first 5 in the bullets. You see, a couple of them have to do with cost, right? Like, what are the real costs to run the application today? People costs and hardware costs and infrastructure costs and other costs. What are my real ongoing BAU run rate costs? Others are, what costs could be avoided? What's the opportunity cost of doing what I am doing versus what I might be doing? Others have to do with agility, like how efficiently am I using my increasingly scarce development resources? Are they in a busy wait state all the time, waiting on some other team, waiting on hardware to arrive? And can I measure that? And what would this migration strategy, what effect would it have on productivity or my ability to respond to business signals outside of it? The one that we've added to the end isn't called out in the white paper, but it's what's the trade-off between time and value, meaning what value can I get by moving quickly, but I might have to trade off on some of these other dimensions. I might not have as big an impact on cost or agility versus, well, if I take a little bit longer, can I get some more benefits? So that's one of the challenges, is how to understand and make decisions along these now 6 axes.
Wonderful. So let's just look at the backdrop of where we are as an industry or industries as a whole. You'll see over on the left-hand side the technology distribution. This is taken from a car software survey from this year. You can see that the breakdown is obviously a large amount of Java, still a lot of COBOL within our industry, and obviously a mixture of .NET and other application languages as well. If you look at the spread when it comes to application size, you can see obviously a fair amount in the 10 to 20K range, and then it starts ramping up. Anything that's from our perspective, anything that's greater than 100,000 lines of code and is a single deployable is a monolith. All right. So you can see the vast lion's share here is starting to go is in that space. Now, this is across 430 applications in total. From my experience working from a variety of companies in the industries over the last 30 years, this is a very small sample, all right? And a lot of them tend to be on the right-hand side of this deck here, all right? So it's very important to understand that we as an industry, we carry a lot of this with us, and that actually is going to limit our ability to be agile, to make changes that are effective to our users. And obviously there's a larger risk because these applications are large and they're single deployables. Every time you do a release, there's an enormous amount of risk inherent in deploying all that code. It's an all or nothing kind of situation. You either roll forward, or if things go bad, you roll back. And obviously that's risk for us and for the companies and the business we serve. Looking at the breakdown here a little bit further across the 3 sort of industries within our sector, insurance, consumer, and investment banking, you can see that consumer does tend to be on the slightly smaller side. A lot of those applications tend to be slightly more contemporary. Obviously, you think about the online portals for online banking and insurance, etc. But when you get more on the traditional side of the house with both insurance and investment banking, they start to get quite large. And that's certainly a pattern that I've seen bear out with my experience. So this is, obviously we do have a lot of monoliths. It's something that we have to deal with, and this is what this pattern is hoping to approach.
Yeah. As Christopher said, those came from Cast Software from their crash reports. If you want some insight and you want to measure your portfolio against the industry, I'd highly recommend it there in the slides, and they're very gracious to let us use their research in our talk. So hopefully we've established that in our industry, odds are, by show of hands and by industry data, we have a lot of monolithic applications. They tend to be disproportionately tied to the core mission and value of the firm, but yet because of cost cost pressures or market pressures, there's a lot of motivation to move. And if we listen to our customers, so Stephen Orban, who was the CIO at Dow Jones for a while and then joined us at AWS to run our enterprise strategy group, he summed up in a blog post, and we've got a quote from it here, this binary choice that most of our customers feel like they have, which is, okay, I've established that this application needs to be migrated for one or more of these reasons we've talked about, but I can either refactor it, now I can rewrite it, I can go cloud native, which is kind of a buzzword, or I can rehost it, I can lift and shift it as is. And most of our customers don't see much of a middle ground. I guess our first observation is that's not strictly speaking true. So this is another artifact from the migration white paper, if you haven't seen it. The two in blue are the two I just described, and we're going to talk about them in just a bit. Those are a little more well understood, easier to get your head around, right? Either I rewrite or I just move it as is, and that's the top and bottom blue path. But just quickly to point out that there are other paths we've seen customers be successful with. That yellow path, which is replatform, is, I think of it in shorthand as I'm probably going to rewrite a lot of code, but I may switch out some infrastructure components. That could be I'm running on commercial Unix and I want to move to flavor of Linux. It could be I'm running on a commercial database software and I might either want to go to a managed version of that commercial software, something like Amazon RDS, or I might want to shift to an open source engine, something like Amazon Aurora or Postgres or MySQL or something. I might want to switch from commercial load balancers, which many are available as virtual appliances in the AWS marketplace, to a managed service like ELB. But I'm not really going to touch the core business logic or code, and the way the application is deployed isn't really going to move. But don't rule that out as an option. So not a pure lift and shift. The orange line too is worth thinking about. If a significant portion of our application is commercial off-the-shelf software through the AWS marketplace and the many partners we have there who are making a pre-configured, always up-to-date version that you can just take as part of your pipeline, that may be a part of your strategy, right? And you can do this at once. And then there are two on the dotted lines to the left. They're always on the roadmap. Some applications have outlived their useful life, and if we're honest, they're not delivering much value. And if we measure that, it may be time for them to find a nice, quiet place in the country to retire and live out their days. The other is, we believe strongly that all applications would benefit from the cloud, but there are limited resources, and you have to sequence that. And some we may just need to pause or delay that decision on whether to migrate, right? So we see these 6 R's that are described in the white paper: rehost and re-architect, replatform, repurchase, retire, or retain. Really just delay. But really, the point of this talk is we're going to talk about a 7th in a bit, this strangler pattern. But before we do that, I want to drill in on the 2 that are tried and true and well understood, because as you'll see, this new pattern tries to get the best of both worlds. So first, let's just think about lift and shift or rehosting for a bit. You'll see the blue boxes are really the work you have to do. Once you've decided it's going to be migrated and then you're going to validate it in production, there are really 2 steps. I need to automate the move. You could do it in a manual way. We don't really recommend that. AWS provides a number of tools to help with the automation. For the data tier, you've got things like the database migration service. If you haven't seen that, it's a managed service that's bidirectional and many-to-many in terms of hopefully the format you have and the format you desire. Could be the same on either side, could be different, and we manage schema and data migration, and it can be an ongoing process, so it's not a big bang cutover. We've got server migration service, which does similar things for OS volumes. We've recently acquired Cloud Endure, which allows you to run in parallel for a while and drain the traffic off in a more natural way, maybe for applications where it's harder to take downtime. So you have lots of options to automate that process. But basically, you decide on your target state, you figure out your automation, you run in parallel for some amount of time, and then you have a cutover, and now you're running in AWS. If we look back at our 6 axes, not surprisingly, this doesn't have a great impact on operational costs. The developers are likely doing the same tasks they're doing before. Your management and operations staff are likely doing the things before. But interestingly, GE Oil and Gas and other customers have reported that just by moving to the AWS platform, even if I haven't fundamentally changed the architecture, they see in the order of 25 to 30% savings. You may say, well, why is that? Well, think about how the hardware was chosen for that platform. You likely went through some sizing exercise. You picked some hardware. If you size too high, right, because you can sort of, well, you can't really trade it back in, so you're running with some waste. Or if the industry got more efficient, right, you are depreciating that hardware over some number of years. The AWS platform allows you to sort of start with the smallest and keep moving up until you meet your non-functional requirements. So pretty straightforward to find, that 25 to 30% savings.
These are green or these are blue? These are green or blue?
It depends. I'm not sure how you account for it. The question, I'm sorry, was are those green or blue? And that just really depends on how you account for it. I mean, from our perspective, smaller instances are billed by the second at a lower rate. So again, if you can run on a smaller instance, your actual bill will be lower. How you account for it, I guess, is the devil in the details. But you see the effects on workforce productivity, except for maybe the people whose job it was to configure those servers. The developers, the folks who are on the deployment and QA team, they're largely doing the same work. Interestingly, you do pick up a little bump in terms of resilience. I mean, if I just have a monolithic application, but I put it into availability zones, I may pick up some resilience without changing the replication pattern that I didn't have before. So what about re-architecture? Who here has been through a real live rewrite, taken a monolith, something maybe bigger than 100,000 lines of code, and rewritten it, and lived to tell about it, and is allowed to leave the office and come to training? Yeah, so congratulations. Many of your peers are maybe still chained to their desks. Because these are very risky, very difficult projects, and you see there's more work for you to do. You first, there's a lot of discussions about, okay, what's our target state architecture? As Christopher was alluding to, someone might say, I love containers, or no, I want to go serverless, or microservices. And so you have a lot of architecture discussions. You pick a target state, you pick some middleware and some tools, and then you get to work. Hopefully you understand and still have institutional expertise on the old system. You understand what right looks like from a business rule standpoint. Sometimes you might have to reverse engineer that and hope that the old system is right. But it's a lot of work, but you refactor it, and then you can deploy it to the cloud. And as you might imagine, when done well, the benefits in terms of agility and cost are high, right? You've been able to pick the most modern techniques and platforms to maximize benefit. The challenge is, you might say, well, why wouldn't we just always do that? Well, time to value is low, right? Like calendar time is what you spend, and that can cost you in terms of market opportunity or missing those chances to get out of a contract. So just to sum it up.
Yeah. So looking at the overall comparison of the strategies, obviously we've put the other ones in from a timing perspective and also from an opportunity to optimize. You can see that rehost is definitely by far the cheapest and the quickest. All right, so it's enabling you to get to the cloud as quickly as possible. All right, it's going to give you some benefits, maybe some stability, some economic benefits, but it's relatively limited and the optimization is low. All right. Conversely, if you re-architecture, the time and effort is going to cost you a lot more, but the ability to get that optimization, that agility is going to be very high. All right. So what we're trying to do here is say we want the benefits of rehosting, but we also want to merge them with the benefits of re-architecture. And that fundamentally is what the Strangler pattern is all about. So let's jump across. So as you mentioned earlier on, it's botany, it's not murder. Effectively, it comes from nature. There are things called the fig tree, for instance, that will surround a host tree. It will climb up it, and it will basically use it as a source of food. And over time, the host tree will die. All right? And that's the analogy that we want to use here. We want to surround the originating monolith application with a series of functional pieces to wither and ultimately die. That doesn't mean that your monolith will go away. I want to be clear, this is a pattern where you have that decision point at some point in its lifespan to keep the original monolith. It might be just, you've done enough and you want to move on and do something else instead, but this pattern will enable you to do that. So, the phrase was coined by Martin Fowler, and basically, as I say, the analogy is around this fig tree that basically consumes the internal one itself, and say slowly over several years. So this isn't something that you have to do and just do very quickly. It's going to give you the flexibility to iterate in a good way, whilst allowing you to add new functionality to the application and service your customers' needs. And that's a key important value when we come to time to value, because you can still provide new functionality to your customers as you're doing this. So let's take a situation here. For our example, we're going to take an online banking a consumer online banking application. Ability for a user to come along, a customer to come along, log in and see their summary balance of their current account, their checking account, their mortgage account, their credit card accounts, all in one place, a portal. Now, in this situation, you're going to have a mixture of functionality. Some things that are called very often. So the summary balance, every time someone logs in, they're going to get that regardless. So that's high volume. All right, it's going to be quite demanding on your application. Conversely, looking at last year's balance for your mortgage is probably not going to happen very often. Right? But it's functionality you still need in there as well. All right? And pinpointing those pieces of functionality that get used a lot is kind of the genesis for the Strangler pattern itself. So in this situation here, I'm going to turn around, you can see the monolith on the left-hand side in our corporate data center. All right? And we've migrated it across. We've done a lift and shift. And we've migrated across into 2 AZs. So we've got some stability here. So we've got some economies of scale, but also we've added some stability as well. We've not done any changes to the database. It's a managed database at this instance. And we've got the instances here running on EC2. And it's running nicely. Okay, so that's the first step. So we've rehosted the application. That's that first bump in the process. The next step is over to you.
Yeah, so you want to put a facade between your existing clients, and those could be multiple clients, right? Web, mobile, even still some rich clients that acts as a smart proxy or a router. We've put API Gateway up there because it has some pretty interesting properties in that regard. In reality, it could be anything that provides those kinds of services, right? The AWS Marketplace has a number of API management software vendors that may be appropriate, but we've chosen API Gateway here. And then sticking with our online banking example, we are assuming that at some point along its life, you've added some sort of APIs in front of it. Maybe went to service-oriented architecture, and these are XML based. But something like API Gateway can target RESTful APIs for sure, but also at any HTTP endpoint, really anything that you can route through. So presuming you have that in place, you put the facade in there, something like API Gateway, and you start to get some things for free. You'll get call metrics, which we'll talk about in a minute, how you can use it, but also throttling, so protecting your backends. This is a problem with monolithic applications. Hey, we're now going to take our backend system, maybe written in COBOL, or the system of record is on a mainframe or some other technology, but then you put the web in front of it, and you have all sorts of saturation problems. So it gives you throttling metrics. It gives you caching, right? So out of the box, you may not have caching in your architecture, but something like API Gateway can say, oh, if the front end continually is asking for that same account balance, you get caching for free without changing any code. But so once you've got your facade up and running in front of the monolith that's now riding on the AWS infrastructure rails and getting some resiliency there, you start gathering metrics. So as I mentioned, one of the things that API Gateway gives you is which APIs are called more often. It gives you other things too, like the latency between when did the API arrive at the front end and how long did it take the back end to service it. And if you start taking these metrics and aggregating them and doing some analysis, you can find the most common code paths in your code. So you can either confirm or disconfirm your intuition, as Christopher was saying. Like, my intuition is that fetching transactions, that all these reads are very common and hotspots and areas where I might benefit from agility, and that I rarely do writes to these places. But we like data at AWS, so you can, as I said, confirm or disconfirm those with actual call statistics. And then, as it turns out, put them to good use as you think about refactoring the application.
Wonderful. Excellent. So before we go on to what we're going to achieve in terms of the splitting, the strangulation of the application, it's worth calling out a couple of things here. So the first one is when you're looking at the functions, the endpoints that are being called, obviously now via API Gateway, you can measure them and you can understand what the hot and cold spots are on your application portfolio, because that's really important. So I would say anecdotally, reads tend to be the ones that get called more often than writes. All right. In this situation of this application, you may have users that come in and want to change their address or their telephone number, etc., but they're not going to be doing that every day. But they are probably going onto their mobile phone and they're checking their balances, or they're making transfers on the odd occasion, but they need to get that information across. So reads are going to be your hotspots at that point in time. So they're the ones that you want to target in an initial load to get some of the load off of the monoliths themselves. The other thing is that, and this is just general throughout software development as a whole, not specific to this, is the 80-20 rule, the Pareto principle, whereby 80% of the calls actually occur on 20% of the functionality, and the inverse is true in the opposite direction. In fact, in my experience, it's like 90-10. In all honesty, there's a very small amount of functionality that gets used over and over again. And I say that's your sweet spot. So when you want to start migrating your functionality across, that's the area you need to go through. And with the previous slide, because we've measured it and you can actually pinpoint it with real data, and you can continue to capture that information as you're going through this process, you have the ability to constantly course correct each and every time you make some changes. So in this instance, what we've decided is to use some Lambda functions. Right, they scale very nicely. It's serverless. And it gives us the ability to create atomic functions that we can deploy in much smaller doses, in smaller amounts, to reduce our risk. All right? And if that's really useful for us, because if you can prove early on that you've got good success in reducing the risk footprint, you'll get more money to do more in the future. And that's always a benefit. So in this situation, what we've done is that we've created some functions. We've not released them yet. We've built them, and we have them coexisting with the original functionality. The next step is to do a Canary release. Okay. So this is important, and API Gateway and Lambda help you to do this, is you have the ability to migrate traffic across in a controlled and iterative fashion. In this instance, what we're doing is the day that we go live, right, the functionality still exists in the monolith. It's not gone away. All right, so if you do need to roll back at any point in time, you just cut the API gateway back to the monolith. But in this instance, we're migrating traffic across 10% every hour to the Lambda functions, slowly but surely. And at the end of 10 hours of period, you've got all the functionality happening over here. Now, that doesn't mean suddenly you just destroy the functionality in the monolith. You probably want to keep it there for a couple more releases, just to ensure that the stuff that's working in the Lambda function is correct. The other good thing about this is you can actually prove, and you can balance between these two to prove that functionality is acting and reacting in the way that you expect it to. Right? So it's very controlled. It's completely de-risked from a release standpoint. So it's incredibly powerful a mechanism to actually do the releases itself.
Yeah, that's an excellent point Christopher's making. We've seen a couple case studies from customers who, even before maybe they cut over production traffic, they just let code flow through both paths and then compare the inputs and the outputs. And you can be data-driven about the accuracy of the new code path, right? And demonstrate to the business that, hey, there's I can quantify the risk of moving to the new code path, which is something that's really difficult to do. Usually you have these big bang, and you say a prayer maybe and hope for the best and hope that your rollback procedures work. Like, not only do Canary deployments allow you to mitigate the risk of rollback, but also, you can have a pre-stage where no real traffic is going, but I can compare the results and analyze their accuracy. But once you've done this, it's really a matter of rinse and repeat. So using the data from the facade, like API Gateway, on where the hotspots are, and assuming that those hotspots correlate to where I'm going to have the most demand from customers, right? So if those are the reads for the front end of our online banking application, right, that's where the competition is, right? That's where this bank has a new feature in their mobile app that we need, and that's where we need agility. That's why we want that code path to be modern and where we can be agile and not have to coordinate a big release, right? And you just keep doing that, right, based on the data. The important point about this slide, though, is, as Christopher said earlier, going back to our pattern in nature, which left alone will eventually kill the host tree and leave a shell that looks like a tree but now is made of vines. That doesn't have to be the end state for your application migration. You may get to a point where we don't have any more hotspots. Those code paths in the monolith are tried and true. They seem to be working. We're not under a lot of pressure to move. And if the cost of maintaining it is low because I've moved it to AWS, yeah, I may leave it alone. But and that's why we call this not with a bang but a whimper, right? No big bang, no cutover date necessarily, no necessity to say we have to get rid of all the legacy code unless there's some other compelling event, some other reason to do so, like the cost of maintaining it or the software contracts or hardware or data center contracts associated with it are cost prohibitive. Then you may want to take it all to the end. But just here to say that the end state isn't necessarily every single thing is moved to a serverless or a microservices or a whatever model, right? Tie it to business outcomes and make sure you can quantify the value of moving it, or don't move it. Right?
Wonderful. So what are the key benefits around this? Well, it's an amalgamation. So whilst you get the you get the benefits of the rehost lift and shift early on, you can then start iterating. And at any point in time, you can say, we've done enough. We're going to keep that monolith. We're going to just maintain it. That's not an issue. It's functionality that gets used once a quarter, once a year, etc. We don't need to worry about that. But we can iterate, or you can iterate as much or as little as you want to at that point in time. So you get the key benefits of both the rehost and the re-architecture. And I think that's a really compelling argument for me, a compelling process to go through.
Cool. All right. So just to sum up, and then we can take some questions. Things to think about it. So Jim Schoellefeld, who's, I guess, the former CEO of Nike, said, with all pun intended, sometimes the right answer is just move it, right? Like, we're thinking too much. See, someone just got the joke. We're thinking too much, right? Like, let's just move it as is with all its warts to the cloud and do minimal refactoring, right? We might have to move from commercial Unix to Linux. We might have to switch up some things, but just get it there. And even in our strangler pattern recommendation, step one was rehost it, lift and shift it, and move it to the cloud. And you may see, as GE reported and others, savings that put money back into your budget for new features just for moving it, right? And that should be pretty straightforward to measure, because the cost to run it will now be transparent, where they may have been a little more opaque before. Rehosting is on one side of the time to value axis, right? Like it should take the shortest amount of calendar time, so you should start, so whatever value is there from the move in terms of resiliency and cost, you should see sooner. But again, some things will remain largely unchanged. Re-architecting, even with the strangler pattern, is one to consider for applications that have a bright future. Right? As you think about your business, think, boy, online banking is going to be with us for a while. It delivers a lot of value. We need that agility to react to the market. Those are the ones to think about. Well, do I re-architect? And then if I'm going to re-architect, is the strangler pattern appropriate? Right?
Yeah.
There may be some applications where strangler is not appropriate, right? Where I have some time. Right, I'm not under great market pressure. I understand the problem space very well. I still have a lot of expertise in the old system, and we have some experience with a modern pattern. And so, yeah, you may not want to go through this iteration. You can just do the re-architecture and do a traditional refactoring of the application, go cloud native. So don't hear our talk as saying we're ruling that out in any way. It's still a valid pattern. But consider the strangler pattern if you need to do both, right? If you need to realize value incrementally. If you're not quite sure, say, hey, we know that we need to modernize our software development practices. We know we need to modernize our architectures. But to be honest, there's still some debate about which ones they are. The strangler pattern can let you try a few of those, right? Yeah. Like you can, if I pick technology stack A for this piece of the application and technology stack B, and see which one sort of works in my culture. Like reworking one of those small pieces, once there's a winner, if there even is a winner, is smaller than saying, oh, I've got to pick one for the re-architecture, and then 6 months down the road, like, I might have picked the wrong one, or the ecosystem changed, or it buys you some agility in terms of architectural models and technology stacks as well. There are managed services in the AWS platform that help you. We've talked a bit about API Gateway, right? So a managed facade that you can put in front that gives you a lot of flexibility and metrics and things that you would otherwise have to manage yourself, like caching and throttling. We didn't even talk about authentication and authorization. And API Gateway gives you many options there, things that might be hard to bolt onto your monolith. This pattern doesn't require you to, using these managed services, doesn't require you to spend to save, right? Like, it's like, oh, I need a modern RESTful API gateway in front of my application. Oh wait, that's more infrastructure that I have to manage. What's the CI/CD and release cycle look like for that infrastructure, right? It can be turtles all the way down, right? Like, so switching out some of those things for managed services, shifting that burden to AWS or another SaaS provider can free up some of your energy and talent to focus on the core business logic. And then, leverage canaries and other modern software development techniques to validate these new features. We talked a bit about canaries, right? So it's getting away from the big, scary, over-the-weekend release where I hope that my rollback plan is sound. And it's like, no, I can validate it. I may even send 0% production traffic down that path and compare the outputs before sending 10% and 20% and slowly moving over at any time to be able to move back. So anyway, that's the Strangler pattern as a new potential migration path. I think it says we have 7 minutes left for
Fantastic.
questions. So,
gentleman there.
in the middle.
So I think it's a great pattern and it makes sense. But I think there's an implicit assumption that there is a big rewrite involved. I think the rest of it makes sense, re-architect. But moving to the Lambda functions, looks like there's a rewrite involved, and you folks know, that's architecture.
Yeah, we picked Lambda as our, we tried to be abstract, but then we wanted to be specific as well. So we talked about API gateways facade. There are many other facades you could use. Same with compute, right? Like Lambda, it has some real interesting properties as compute, but you're right, if your application isn't easily decomposable into small functions where I can just say, hey, run this function on this runtime with these dependencies, you're right, maybe something like containers or even virtual machines, right, because they can be fully automatable are an interim step, but those could be smaller and less shared by other code paths, right? So don't hear us as saying that Lambda is the only way to pull this off.
Correct.
You can use other types of compute, could be containers. There are lots of services to help you use containers without doing a lot of the heavy lifting on the platform. Same for virtual machines. But yeah, we just chose Lambda for the talk.
So do you see a lot of rewrite or do you see a lot of porting of the code?
A combination. So, API Gateway is great. In fact, you just don't have to direct down onto Lambdas or onto containers. You could even do direct calls to services that we offer, managed services. So you don't necessarily have to write code. If you're doing lots of reads on a data structure, well, you don't necessarily need code in that instance. It's just a call request at that point in time. So I think that there is an inherent probably need to do some rewrites. What we're trying to focus on with this is so that you can scale the pieces of your application that need to be scaled. Obviously, traditionally, you would scale them in a vertical, just add more memory, add more disks. It's very easy. That's how we used to do it in the data centers. But you want to change that so you can scale horizontally. All right, and so monoliths just don't have that in nature. Or if you do scale them horizontally, the problem being is that you're scaling everything for every instance you're running. In this instance, by using something like Lambda, you're just scaling that one function, that one call that you need. Maybe it is the balance requirement, the balance summary when you log in, etc. Yeah. So I think you just have to pick your battles, but this pattern enables you to pick them. All right, and I think that's the key difference here. Yeah. So rewrite as much or as little as you actually want to, but focus on the areas where you're going to get the most value.
Yeah.
You focused initially on moving the reading of data.
Yeah.
A lot of the trouble and the challenges with monoliths come when you have to update system of record, and system of record is the part that's not actually the scalable solution. Do you have any thoughts and ideas of how to do that without completely rewriting a database architecture, which can be very difficult?
Yeah. So one of my customers I'm working with right now is doing just that. They're traditionally an RDBMS structure. They're pulling parts of that apart as they go. Some of the read structures they've got require sort of more unstructured data. And so they're using triggers in some instances and pipelines to convert data as it's coming in and then storing it separately so when the read requests come down, they've got them. But structuring writes, making them atomic or reducing their atomic nature is very difficult. There are patterns there that you can use happily to discuss it afterwards. In that case.
And API Gateway is built for sort of internet scale, born in the cloud applications, and so we built throttling in. But when you apply it to enterprise applications, it can have some interesting properties, right? So if you're worried about saturating, the back end, it can give you those sort of queue things up without you doing any work. So that's one way. That's not, I know, the only reason that the back ends get under pressure. But if it's just a pure throughput, you might get some benefit from throttling in the API gateway layer.
But to your point, for instance, if you're looking right now, the monolith does everything and then suddenly returns after X. You might be looking to decouple some of that writes so that you can stage it in some shape or form. And obviously, we've got step functions, which are obviously in our serverless portfolio, that you can use to help do that in a more thoughtful fashion. In that respect.
Cool. Okay.
Yeah.
speak a little bit about, cost versus performance?
In terms of
Re-architecting
cost performance.
and the race against time.
So we're going back to sort of here-ish, what you're talking about. So clearly on this one, in terms of cost that you invest to make the jump, it is the cheapest. All right. Here, if you're rewriting an application, especially a monolith, it's got 500,000 lines of code. First and foremost, the likelihood of you having the original developer with you, or the original developers with you, is going to be scant, in all honesty. So there's cost involved in actually finding someone who understands what's going on, or finding someone who can go and actually, backwards engineer an application. All right. By porting it down here with the strangler, lift and shift, and then just focusing on single pieces of functionality, you're going to reduce the risk, you're going to reduce the cost as well, because they don't need to understand the entire ecosystem. I also believe that performance will improve, because if you're focusing on those, that top 10% of functions that get called 90% of the time, and you can scale those effectively, all right, then your performance of the overall application is going to be increased in that respect. Does that answer your question? I'm not sure if it was. Okay.
Maybe time for one or two more, depending on how verbose Christopher and I are. None?
No?
Wow.
Cool.
I don't believe we've answered them all. So if you have more, we're around.
Yeah.
So we'll probably be in the hall, but I assume we'll have another. Well, we're coming up on a break. So we'll be up front for a bit, and then we'll be in the hall after they kick us out.
Thank you.
Thanks, guys.
That's good. 1 minute.
Yeah. Good job.
That's good. That was excellent.
I thought the